Hello, everyone. My name is Joshua Jitomobi. It's my pleasure to welcome you to an introductory class on matrix algebra. Introduction to matrix algebra. What is matrix algebra and its application in agricultural economics or related courses? A matrix is an arrangement of numbers into rows and columns. The numbers of row by the numbers of column is the matrix dimensions, while the contents are the elements. In terms of its application, matrix is applicable in any quantitative field. It's particularly useful in solving systems of linear equations and linear approximations. And this is unavoidable everywhere. In solving the use of demand for industries, it has found application in input-output models. And it is the backbones of econometrics for some of us in economics. And by the time we conclude the introductory class, you will find it extremely useful by the time you are being taught econometrics or input-output models. In terms of mathematical representation, for instance, this is the rectangular representation of a matrix, matrix A, which is equal to Aij, I standing for row and J standing for column. So when we have A11, for instance, that is row 1, column 1 of matrix A, A12, row 1, column 2 of matrix A, AMN, that is row M, column N of matrix A. When we are talking of the dimension, it is row first, then the column. Please take note. For instance, for a 2 by 2 matrix, it will be A11, A12 for row 1, A21, A22 for row 2. And for a 2 by 3 matrix, that's talking of 2 rows, A11, A12, A13, A21, A22, A23, and 3 columns, A11, A21, A12, A22, A13, A23. Please take note because often many students do confuse column with row, particularly when the dimensions are not equal. Quickly, let's go through some types of matrices. The simplest is what is called row vector. That's a situation whereby you have just one row. Now you can have many columns, but it's just one row. The other is column vector. That is a situation whereby you have just one column. You can have many rows, but it's just one column. The third type of matrices, that's square matrix. For square matrix, the row is equal to, the number of rows is equal to the numbers of column. For instance, you may have 2 by 2, 3 by 3, 4 by 4, 5 by 5, 100 by 100, and so on. Another type of matrix is diagonal matrix. It's a square matrix in which every element except the principal diagonal elements is 0. In terms of mathematical representation, we have matrix A to B, D1, D2 to Dn along the principal diagonal. Those are the principal diagonal elements. Every other element of the matrix is 0. And this takes us to the trace of a matrix. The trace of a matrix A, designated by TRA, is the sum of the elements on the main diagonal. So let's fix there, for instance. Let's say, let us have a 2 by 2 diagonal matrix, for instance. Okay. 2 by 2. So let me call my matrix. Good. So for a 2 by 2, let's say this is 2. For sure, this will be 0. Let's say this is 3. And for sure, this will be 0 because these 2 and 3 are the principal diagonal. So let's say we have A equals here. So the TRA, that is the trace of this matrix A, equals 2 plus 3, which is equal to what? 5. So that's what we are trying to say. So the trace is adding together the elements along the principal diagonal. It could be 3 by 3, 4 by 4, whatever. Another type of matrices is equal matrices. Two matrices are equal if the elements, even corresponding elements, are the same. Take, for instance, we have our A to B. 1, 2 for row 1, 3, 4 for row 2. If and our B equals to A, B, C, D. If A equals to B, then A equals to 1, B equals to 2, C equals to 3, and D equals to 4. Zero matrix. For zero matrix, all the elements are 0, whether 2 by 2, 3 by 3, 2 by 7, whichever. All the elements are 0. For identity matrix, it's a square matrix where the principal diagonal elements are 1 and every other elements are 0. So let me illustrate with a 3 by 3 matrix, for instance. It's a 3 by 3. Let me illustrate with 3 by 3 matrix. Insert the equation. So they have, so it's a 3 by 3 matrix. 3 by 3 is 3 by 3. So let's see, A equals, so what we are saying, this will be 1, this will be 0, this will be 0, this will be 0, for sure this will be 1, this will be 0, then this will be 0, this will be 0, this will be 1. So you can see that the elements along the principal diagonal are 1. So every other element are 0. This is typical of identity matrix. The transpose of a matrix. Transpose of a matrix is exchanging the row for column or column for row. Take, for instance, we have A is a column vector, 2, 8. And for B, it's a 3 by 3 matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for C, we have it as 0, 1, 2, 4, 1, minus 1. To transpose A, it will become a row vector. That is, this 2, 8, which is a column, becomes a row. For B, row 1, which is 1, 2, 3, becomes column 1, which is 1, 2, 3, and so on. For instance, for row 3, which is 7, 8, 9, becomes the column 3, which is 7, 8, 9. And for C, we have 0, 2, 1, which is column 1. That will become row 1, which is 0, 2. And 1, 4, minus 1, which is the second column, will now become the second row for the transpose of the matrix. In terms of properties of transposes, if you transpose the transpose of a matrix, then you will obtain the original matrix. If you add two matrices together and obtain the transpose, it's as good as adding the transpose of each of them together. If you multiply a matrix by a constant, let's say C, and you obtain the transpose, it's the same as multiplying the transpose of the matrix by the constant. If you multiply two matrices, say A, B, and you obtain the transpose, it's the same as multiplying the transpose of the second matrix with the transpose of the first. And you can come up with any example. Let's say A equals to certain matrix, B equals to, and you can demonstrate all these things. And you will see that the properties actually exist the way that we have stated it here. Another type of matrix that we need to pay attention to is symmetric matrix. It's a square matrix where the matrix is equal to its transpose. Square symmetric matrix is a square matrix where the transpose of the matrix is equivalent to negative of the original, or where A, that is the matrix, is equivalent to negative of the transpose. Look at this example, for instance. A is 1, 2, 3, A, 4, 5, B, C, 6. Is symmetric, find A, B, C. What we just need to do is transpose this A. If you transpose, you have 1, A, B, C, 2, 4, C, 3, 5, 6. And look at the values of A, B, C then, which is 2, 3, 5. That is how to go about solving the problem. And in terms of square matrix, if A is 0, 1, 2, A 0, 3, B C 0 is a skew symmetric, find A, B, C. What we need to do, obtain the transpose of this A, multiply by -1 since it's negative. So you have 0 minus A minus B, what you have here. And in that wise, your A -1, B -2, and C equals to -3. And Don't forget, this is the property of a symmetric matrix. We have A multiplied by its transpose and transpose. Then you have the transpose of the transpose multiplied by the transpose, which is equivalent to multiplying the original matrix by its transpose. Matrix addition. Matrix addition. For matrix addition, it is important that the two matrices have the same dimension. It's a condition that should be met. For instance, here we have 2 by 2, and the other one also should be 2 by 2. And you add the corresponding elements. Here we have minus 1, 2, 1, 3, 0, 1, plus 1, 2. So if I want to add, this is A11 here, this is B11. So that's what I'm going to add. This is A12, and this is B12. That's what I'm going to add. You can see, super simple. So that is how we obtain the 0, 5, minus 1, 3. The same apply. This is a column matrix. Another column matrix. This is 3 by 1, 3 by 1. So add it, and you end up adding a 0 matrix. There is what is called scalar multiplication. Scalar multiplication is multiplying a matrix by a constant. Take, for instance, we have our A to be 1, 2, 4, minus 3, 0, minus 1, 2, 1, 2. To calculate 3A, that is, you want to multiply this matrix by this constant A. And you have your B to be 2, 0, 0, 1, minus 4, 3, minus 1, 3, 2. And you want to multiply it by minus 1, get your minus B. So if that is the question, what you need to do is to multiply each element of the matrix by the constants. This is what we're trying to say. In this case, you multiply each element by 3, and that is how we obtain this matrix. In this case, you multiply each element by minus 1. This is how we obtain this. And don't forget, we have 3 by 3 matrix. B is 3 by 3, 3 is 3 by 3, so you can subtract, or you can add, whichever, depending on the question. This is where we're going to stop this introduction. So far, so good. Today, we have looked at the definition of the matrix. We have looked at various types of matrices. We have considered matrix addition and multiplication of a matrix by a scalar. Thank you. Till we meet again to continue the lecture. Stay blessed.